go to this table right here on the page that we left off at. There are three types of binary compounds. Binary compounds are those that contain two elements. We'll have polyatomic compounds later on that have more than that, and we'll have a specific way of doing that. But for now, today, we're going to deal with just binary compounds. And we already talked about the simplest type of binary compound, the fixed charge ionic compound that has a metal cation, a non-metal anion. We learned how to predict charges from elements within certain groups on the periodic table, right? Like group 1A are all plus, group 2A are 2 plus. We talked about aluminum and gallium. I'm going to give you a couple more in a little bit. But just pretty much based on their position on the periodic table, we can predict their charge. Okay? And same thing with the nonmetals. Those are all negative charges because we're gaining electrons in order to be stable like a noble gas. So minus, 2 minus, 3 minus, going over like that. Okay? So calcium chloride, CaCl2, has that formula because calcium is a 2 plus charge, chloride is minus. We need 2 of these chloride ions in order for the compound to be neutral, right? In order for all the pluses and the minuses to equal each other out. Okay? So I need a 1 to 2 ratio. We sort of switch those charges around to figure out what ratio of those ions we need to make a neutral grouping of ions, something that has no charge overall. Okay? So we talked about group 1A, group 2A, aluminum, and gallium, but there's a whole lot more of the periodic table that we didn't talk about, right? We talked about these are plus, these are 2 plus, aluminum and gallium. Okay? There are a whole bunch of other metals. What did we call this section of the periodic table in the middle? Metals. Yeah, they're metals. What kind of metals? Transition metals. So the transition metals are sort of not accounted for in this, as well as some other of these main group metals over here. Okay? We talked about aluminum and gallium, but we didn't talk about tin and lead and antimony and bismuth, okay? Things like that. So let's talk about variable charge ionic compounds. So we'll come back to fill out that column here. Let's go to this page, start talking about what that means. So the transition metals, okay, for the most part, the metals in the middle part of the periodic table, they do not form a single stable ion like nonmetals do, or like 1A, 2A, aluminum, yeah, right, 1A is plus, 2A is 2 plus, okay? We talked about gaining or removing electrons to get to a noble gas configuration, okay, for those predictable ones. But transition metals and various other elements, there are multiple ways that they can become stable. And the specific way they do that, that'll become a lot clearer later on when we talk about specifically where these electrons are all going inside of the atom. That'll make a little more sense. But for now, it's enough to say that transition metals and the other things that we didn't specifically account for so far, they can form multiple different stable ions. They have lots of ways of becoming stable. Okay? Not just one single charge that we can predict straight from the periodic table. So for instance, the iron cation in different compounds can be Fe2 plus or Fe3 plus. Okay? There are some iron 2 plus compounds, some iron 3 plus compounds. Just so happens that those two are both stable ions that iron can make. And other transition metals have a similar sort of deal. They can make 2, 3, some of them make several, like 6 different ions. Okay? So for that reason, a name like iron chloride is an incomplete name. Okay? We know that it must be ionic because iron is a metal, chlorine is a non-metal. Okay? We do know what chloride's charge is, right? Look on a periodic table here. What charge would Cl make? what does it need to do in order to become stable? It needs to gain 1 electron, right? So what charge would it have? Minus? Single minus? So we know that. Cl is minus. Okay? But iron, we don't know what its charge is. Okay? Straight from the periodic table, it's right in here. We're not going to count all the way back to a noble gas. Okay? In a lot of cases, that would be 8 or something like that. 26 minus 18. Okay? That's too many. So just saying iron chloride isn't enough. So let's go the other way. Let's look at formulas for 2 different known compounds that iron can make with chlorine. Okay? FeCl3 is a known compound. Okay? It contains a 1:3 ratio, okay, of iron to chloride ions. Okay? So its ion pair, Fe, right, and we don't know what its charge is right away, so let's make a little box there because we'll come back to that. We do know that chlorine is minus, okay, but given this ratio, okay, given that I'm going to have 1 of these and 3 of these, what charge would this iron have to have in order for the compound to be neutral? 3 what? Minus? Okay. Has to be 3 plus. Okay? This iron to make the compound neutral. In other words, what we're representing here is 1 of these ions and then 3 of these ions, Cl. Okay, that group is neutral. That makes sense? That's really what FeCl3 is made up of. Okay? Now, it's an ionic compound, so they're all stacked up, okay? Kind of alternating, 1 iron in between 3 chlorines, but all stacked up. Okay? But that's the simplest unit. That's the simplest group, or the smallest repeating group of those ions that are all stacked up. Okay? So FeCl2 is another compound that iron makes. It's a 1:2 ratio. It's ion pair Fe, and let's draw a box there because we don't know just yet what that is. Cl we always know is minus. Okay? Looking at this ratio, what charge would this iron have to be? 2 plus? Okay? So, we said before that iron chloride is an incomplete name. Okay? We now know that FeCl3 has iron 3 plus ions. This one has iron 2 plus ions. We're going to reflect that in the name. Okay? The name of this one, iron Roman numeral 3 in parentheses, chloride. The name of this one, iron Roman numeral 2 in parentheses, chloride. Okay? Because the name iron chloride alone isn't enough because we don't know which charge iron happens to have. But iron 3 chloride is the name for FeCl3. Iron 2 chloride is the name for FeCl2. So what do you suppose that Roman numeral directly represents? Yeah, the Roman numeral in parentheses indicates the positive charge on a variable charge metal cation. Okay? So that's the new thing that we need to deal with right here. When we have a metal that in different compounds can form different charges, we need to, as part of the name of that compound, we need to say which charge that metal has, whether it's 3 or 2 or 1 or 4 or 6 or whatever. Okay? And we can usually figure that out from the formula. So let's try a couple. let's start with these ones where I gave you a name. Okay? In ionic compounds, the name directly represents the ion pair. Okay? The name of ionic compounds, it's the name of the cation and the name of the anion. So literally, we're naming what the plus ion is and what the minus ion is. And that's going to be important, especially when we start thinking about this. Okay? So let's write the ion pair for titanium. What is IV Roman numeral for? 4. Yeah, because 1 before 5, right, means we remove 1 from the 5. So IV is 4, VI is 6. Okay? So titanium is our cation. Okay? Titanium is right here on the periodic table. Not one of the ones whose charges we know, right? Because these are plus, those are 2 plus, 3 plus. Okay? Everything in the middle that could have kind of whatever charge depending on the compound that it happens to be in. Okay? Based on this compound right here, how do we know what charge this titanium has? Look back right here. Okay. So what charge is the titanium in this compound? 4 what? 4 plus. Metals are always pluses, okay? But that's important. If you're given a name, okay, that has a Roman numeral in it, that Roman numeral is just straight out telling you what the plus charge is. That's it. Okay? So Ti4 plus. Chloride is always what? Minus. Good. Okay. So these are the ions that we have to deal with, Ti4 plus and minus. What ratio of those two ions do I need for it to be neutral? 1 to 4. Okay. We need a 1 to 4 ratio, just switching the charges, right? Because we're going to need more of these. Right? For every one of these, I'm going to need 4 of these for them to equal out. Okay? And in ionic compounds, the ratio is exactly what the formula is. Okay? It's just the formula has the elements in it. So this formula would be what? TiCl4. Okay? The formula is just kind of telling us how many of each thing we need. All right. So Ti, what charge does this one have? 4 plus again, because of the Roman numeral. Ti4 plus. What is oxide? O, what charge? 2 minus, okay? You can switch the numbers around if you want to get a ratio. But what was the other thing I told you about a ratio? If you switch these, you get 2 to 4, but that's not the true ratio. Yeah, ratios for ionic compounds need to be reduced. Okay? So what is the actual ratio that we need here? We need a 1 to 2 ratio. And actually, just sort of looking at these, you should be able to see that in your head. Right? If I had one of these, I would need 2 of those. Right? I'd need 2 minus and another 2 minus to balance out the 4 plus. Right? So, but we can say reduce from 2 to 4 for that. Okay? So, formula, Ti, formula comes right from the ratio. So, TiO2. Okay? So, titanium 4 oxide is TiO2. Hopefully you can see here that writing out the ion pair is of critical importance in order to get these formulas right. Okay? Because titanium 4 oxide is TiO2. Without at least thinking about what those charges are, it would be tough to get TiO2 from titanium 4 oxide. Okay? But that Roman numeral means something specific. I'm going to ask you this several times today. What does that Roman numeral mean? It is the plus charge on the cation. Okay? It's the plus charge on the variable cation. So That's telling you. So it's actually pretty easy if you are given something, a name with a Roman numeral, because that's telling you right off what the charges are. If we go the other way, we have to do a little bit of thinking. We have to do a little bit of problem solving to figure out what that charge is. Okay? So let's start with these formulas. Remember, again, the formula and the ratio are pretty much the exact same thing. So what ratio is this formula suggesting? WF6. Yeah, that's suggesting a 1:6 ratio. Over here for ion pair, let's do W. That is right down here. It's variable charge. So let's draw a box. We don't know yet what its charge is. So let's go on to the anion. What is F's charge going to be? Yeah, single negative. Okay? So you'll always know what the minus charge is. Okay? You'll figure out then what the plus charge is. Okay? So think about this ratio. Think about that's how many of these you have. Okay? What charge do you think that W has to have? What do you think? 6? 6 what? It's 6 plus, because don't forget what this ratio means. 6 means that's how many of these F minus ions we have. 1, that's how many of these W ions I have. If I have 6 of these, okay, and 1 of these, I'm going to have 6 minuses, so I'll need a single 6 plus here for that one. Okay. This one was on the element quiz. For some of you, what is W called? Okay, well, that tungsten. Okay, so this compound will be called tungsten what? Tungsten 6. So parentheses, Roman numeral VI. If you're typing this in like Mastering Chemistry or something, just use capital letters, capital V, capital I. Okay, put them in parentheses. Notice there's no space here, okay, because that W6 plus ion, that is the tungsten 6 ion. Okay, that's the first word. Okay, and then the second word is what the F minus ion is. What's that one called? That's fluoride. Okay. Good. All right. Now, that one wasn't so bad because you can clearly see that the ratio and the ion pair are just numbers switched around, right? But it's not always that way because the ratio is always reduced, okay? But the charges are whatever the charges are. Okay? The charges may not be reduced. So when you have a reduced ratio, going back to the charges requires a little bit of gymnastics. So let's do this one here. 1:2 ratio. Okay? Remember, the ratio is just straight up what that formula says. Don't do anything fancy turning a formula into a ratio. Okay? Mn, draw the box. P, what I want you to do, I want you to maybe look at a periodic table, write what P's charge is. Okay. And then I want you to think about the ratio. Okay? You've written a charge for P. What is it? How many? Okay. You've written a charge for phosphorus. Okay? What does this number 2 here mean? That's the ratio, and what does that mean? That means you have 2 of these, right, in the formula. Okay? And this 1 means we have 1 of those in the formula. Okay? So if I have 3 minus and I have 2 of them, what charge does manganese need to have there? It needs to be 6 plus. Okay? Manganese what? Vi 6, manganese 6. And what's P3 minus called? Phosphide. Okay. A lot of you probably could have called this tungsten 6 fluoride. Eh? But how many of you could look at MnP2 and say that that's manganese 6 phosphide? Eh? That's why, again, it's so important that you understand what the ratio here means. Okay? That you start with the charge of the ion that you know, okay? And looking at that ratio, figure out what the unknown charge has to be. Okay? And if you like algebra, there's a way to do that algebraically. Okay? But I think practically, really the best way to do it is to think, okay, what does that ratio mean? What is the charge that I know? How many of those do I have? What does the unknown charge have to be? Okay? We did O before it's 2 minus, okay? There are times, like this one, where you can actually tell that the charges were just switched around. Okay? How in this one, before I figure out that unknown charge, how do I automatically know that those two numbers are just switched around in this one? Because I've got 2 coppers, right? And over there in the charges, the other one is a 2 minus charge, right? So if this charge right here that we know is the other number in the ratio, then that means the 2 numbers just had to be switched, right? So that's not so bad. What would be the unknown charge here then? Yeah. So you have to be careful with that because that doesn't work up here, okay? How come that didn't work up here? How come I couldn't just say 2 plus in the box right there? Because this is a reduced ratio. See that? If we were starting with these charges, we would go 3 to 6, and that reduces to 1 to 2. Okay? So I don't know if you want to make a little note of that. That is a reduced ratio. And you can't tell that just by looking at the ratio, but you can see that if your known charge is a 3 and you don't have any 3's over here, that it's a reduced ratio. That sort of makes a little more sense with that. Okay? Copper oxide. Copper 3 oxide. That's better. Okay. I'm going to show you a couple of ways to sort of check your work here. And again, any way that you can get a picture of this in your head somehow, it's going to help quite a bit when you're figuring out those unknown charges. For instance, this manganese 6 phosphide, MnP2. If we do like we did before, you can draw out those ions, right? Here's an Mn6 plus ion. Okay. Here's 2 of these P3 minus ions. Okay. That is a neutral group. See how that works? What we were figuring out, the unknown was right in there. Okay. So if you wanted to, if you're trying to figure that out, you could do something like that. Okay. We know P is 3 minus. We know we have 2 of them, so I'm going to draw 2 of them. I know I have 1 of these manganese ions. What charge has to be in that box to make this group neutral? Okay. That's one way of doing it. You can do it sort of written out a little bit. If I have 1 of those manganese ions, and I have 2 of those P3 minus ions, okay, we know that 2 of those 3 minus, that makes 6 minus total. We know that we're going to need 6 plus total for it to be neutral. Okay, so that means in the box here, has to go that 6 plus. Okay. So essentially what we did here, I multiplied the known charge, okay, by its ratio. Okay. And then what we really have to do is divide by the ratio for the unknown charge. Okay. So That's if you're totally into a little bit of algebra, you can do it that way. But honestly, I think it just works totally fine, just sort of making a little bit of concept about it. The reason this 2 to 3 works, again, hopefully you can see, if I have 2 of those copper 3 pluses, so maybe make 2 boxes for those, and I've got 3 of those O2 minuses, again, that's a neutral group, okay, which would look like 3 O2 minuses is 6 minus 2. That tells us that our unknown charge has to be 3 plus. So again, I sort of multiplied the known charge by its ratio, and then I took that and divided, okay, to figure out that unknown ratio. But you can usually just do that in your head. So whatever kind of way works for you, okay, if it's kind of drawing up the grouping, figuring out what it is, if it's writing it out with the totals, okay, or if it's just kind of thinking about it in your head, you need that idea that these ratios are how many we have. These ion pairs have the charges, along with an unknown charge in there if it's a variable charge compound. Okay? So let's mix it up just a little bit, because in this table right here, I've thrown in some fixed charge metals, okay, from before. So type in this should be fixed or variable. And that's looking at the metal. Okay? So we had, and if you want, you can look at here, we listed which fixed charge metals we know about so far. Okay? All of these in this are ionic, because it's a metal and a nonmetal. But I want you to figure out, first of all, whether it's fixed or variable, just based on the metal. Okay? Write the ratio straight from the formula like we did before. Write the ion pair, that's where you write all the charges, and then write the name. So I want you to see if you can give that a try. But first stop is to check that metal, see if it's one whose charge we know already, or one whose charge we're going to have to figure out. Ratio is the numbers from the formula. So let's see how we do. In that first column down, you should be writing fixed or variable. Or you could write F or V or something if you want to abbreviate it. Only the variable ones will have Roman numerals. The fixed ones, those are the ones we did before the exam. Those are just like sodium chloride or something like that. For fixed or variable, look at the metal. Look at whether that's one whose charge we've already talked about or not. We talked about group 1, group 2, aluminum and gallium. Those are the fixed ones. Once you start getting some names, compare them with your neighbors. See if you got the same thing. Remember, only the variable ones will have a Roman numeral. And the variable ones need the Roman numeral to show what the charge is. When you're writing the ion pair for a variable compound, start with just the box for the charge of the metal. Go on to the non-metal, that's the charge you know, then look at how many of those known charges you have from the ratio. Chromium. And Ni is not nitrogen. Nitrogen is N over here. Ni is a metal. Especially compare with your neighbors what the Roman numeral is for the CR. That's the one that I'm seeing some variation on. Remember, start with the known charge. Start with the known charge of the minus one. Ask yourself how many of those I have and what the plus has to be to balance that out. Okay. That's our known charge. Look at how many of those you have. You've got 2 of those 2 minuses. So what will that have to be if I have just one of those? What will that have to be? Well, that would work if I had just one of them. But yeah, I've got 2 minus times 2, essentially. Okay. Okay. So the first one, K2O, is that fixed or variable? That's fixed. What tells you that K2O is fixed? Yeah, the metal is potassium, right? K, we've got a periodic table on the next page here. We can do that. Okay. Group 1A, those are all pluses. Group 2A, those are all 2 pluses, fixed. We could go all the way down. Aluminum and gallium, 3 plus. Okay, so those are the only fixed ones we know about so far. So, fixed. The ratio is just literally what the formula says. Don't get fancy with that. That's 2-to-1 ratio. When it's fixed, you can just write out what the charges are, just straight from the periodic table. What is K's charge? Plus. What is O's charge? 2 minus. Okay? And to name it, we name it from those elements. So, potassium, that's K, right? Should I put a Roman numeral here? When it's fixed charge, just saying potassium is enough because potassium is always plus. We can write a plus right on the periodic table there. So no Roman numeral after potassium. It's just potassium. Okay? Okay. No Roman numeral for fixed metals. Okay? So, not so bad. Cr is variable, right? It's right in here somewhere. Okay? It's a what ratio? Okay? The formula tells us that I have one Cr for every two of those O's. Okay? Cr is variable, so let's do a box and go on. O is 2 minus, just like we saw before. Okay? Now, this box right here was a place where I saw some variation. Okay? I saw 1s and 2s and 4s in there, pretty much. Okay? So again, you have your known charge, which is 2 minus. The ratio tells you how many of those you have, okay? Which is we have 2 of those. We have 2 minus, but we have 2 of them. So it's like 2 minus times 2. Okay? So because we only have 1 of those chromiums in the formula, then that 1 chromium has to take on the entire charge from 2 of those oxide ions. Right? So what charge would the chromium ion have to have? Yeah, the chromium is 4 plus 2 minus times 2. Okay? That's the total minus charge. And then because we have only 1 of these, that's going to take on the entire plus charge to balance it out. Okay? So Cr chromium, Roman numeral now. Roman numeral what? Yep. And I'm going to do it in red here so it matches. Chromium 4 oxide. Okay? So double check. If you did not write Roman numeral 4, okay, that means what you forgot to do, you forgot to look at the known charge and then look at how many of them there are. 2 minus, and there are 2 of them in the formula. Okay? All right. Fixed or variable on MgI2? Okay, so we know how to do that. 1 to 2 ratio. Mg, what charge? 2 plus. I, what charge? Single minus. Mg, magnesium. Magnesium, what? Yeah, nothing fancy. And it's an "-ide", because it's a minus there. Magnesium iodide. That's all that is. That's not too bad. Ni, that looks variable to me. The transition metals. Here is a 2 to 1 ratio. Get my colors. There we go. Ni, draw a box, go on. O2 minus. Okay. So look at it this way now. O is 2 minus, and I have 1 of them. So my total minus charge is 2 minus. I'm going to need a total plus charge of 2 plus, right? But I'm not going to put 2 plus in the box there. Why not? I have 2 of those nickel ions in the formula. So the total charge has to be divided amongst how many nickels I have in that formula. Okay? So I need 2 plus total, okay? But my formula has 2 nickel ions in it. So what we put in the box is what goes on each of those nickel ions. Yeah, it's just a single plus. In ones like that, drawing it out is pretty helpful because it would look sort of like this. Here's a nickel. Here's another nickel. Here's a single O2 minus. And that is our neutral group. If that's the case, a plus has to go in each of those boxes, okay, to make it neutral. Okay? 2 2 is a very common incorrect answer for that. 4 would be a very common incorrect answer for that. Okay? But again, here's my minus. I have 1 of them. Here's my plus. I have 2 of them. Okay? Nickel what? Nickel Roman numeral. We need a Roman numeral anytime it's variable charge, even if it's single. We need a Roman numeral because otherwise we don't know what charge we're talking about. So nickel Roman numeral 1. Nickel 1. Nickel 1 oxide. Okay. Don't forget Roman numeral anytime it's a variable charge metal. Don't forget it. Okay? Does everybody understand where the 4 came from and where the 1 came from in those Roman numerals? It's a really important concept, and if you miss that, or if you're a little hazy on that, we'll get more practice on doing that in just a second. But it's going to be very important that you understand what those come from just as we go. Okay? So let's once and for all make a complete list of which metals are fixed charge, so that we know the ones that are variable charge. Okay? So what were the groups on the periodic table that we've talked about that are fixed charge so far? What are the group numbers that we know? 1A and 2A, right? 1A is plus. 2A is 2 plus. Okay? And then what are the other fixed charge metals that we've talked about so far? Yep, aluminum 3 plus, gallium 3 plus. Okay? Those are the ones we've talked about so far because that makes nice sense about losing electrons to get to a noble gas. Right? I'm going to add 2 more fixed charge metals for you right now. Okay? They are zinc, which is 2 plus, and silver, which is plus. Okay? So on our periodic table, they fall into a nice order because here's zinc, 2 plus, and here's silver, plus. Now, obviously, those do not have a noble gas electron configuration. Okay? You're going to have to trust me on that for a little while because we have a whole big conversation about electron configurations later for that to make a little more sense. Okay? But I promise I won't add any more fixed charge metals for you. So what we can do, we can say fixed charge cations are pretty much just these. Okay? We can draw a nice box around those. We can draw a nice little box around these. Okay? Those cations, okay? 1 plus, 2 plus on the left, going backwards, 3 plus, 2 plus, 1 plus for aluminum, gallium, zinc, silver. Okay? Those are the ones that we can always count on to have particular given charges. In their names, there will be no Roman numeral, even though zinc is a transition metal. Because it only forms a 2 plus ion, something like ZnCl2 is just called, well, it has Zn2 plus, it has Cl minus in it. It's just called zinc chloride. Same thing for silver. There's silver oxide and silver fluoride and silver bromide and so on. Okay, no Roman numeral. And while we're at it, before we forget, let's go back a couple of pages to our table here. Okay, and let's fill in zinc and silver right there. Hopefully you left a little bit of room there. But for our fixed charge metals, let's aluminum, gallium, zinc, and silver. Okay? And while we're here, let's fill out the second column here. So we're putting this in a couple places, but that's okay to have some extra practice here. variable charge ionic compounds, they will again have a cation and an anion, just like, where am I going here? There we go. Just like our other one, a cation, some plus, anion, some kind of minus, okay? But now a variable charge metal we'll say the transition metals and etc., because I'll show you those exactly in just a second, okay? But a variable charge metal and a nonmetal. The variable charge will be some level of plus, okay? It'll be because all metals will form plus ions. Okay? So there'll be a plus and a minus. It's just a variable charge plus. So the difference in the naming comes from if we had FeCl3, that's made out of Fe3 plus variable Cl minus, and it's called iron 3 chloride. Okay. And that Roman numeral, tell me once again, what does that Roman numeral stand for? The what charge? Yep, the positive charge of the variable cation. Okay? So that's the difference between fixed and variable. They're both ionic because they're both a metal and a nonmetal. Okay? That's right. There's a good place to write that. How about right here? Ionic. Okay. The difference is which metal we're talking about. Is it a fixed charge metal or is it a variable charge metal? Okay. So let's go back to this page with the fixed or variable, okay, with our list of metals here. We specifically showed the fixed charge cations. Say cations there. Okay. All the other metals are variable charge. Okay. Including the metalloids over on the left here, including these in the main group. Okay. Including the inner transition metals down on the bottom. So let's include those. Copper, palladium. There we go. All of those. Variable charge cations. Okay. So for our list over here, we're probably not going to list out every single one of them. How about let's just say all other metals. Okay. Transition metals. Inner transition. Okay. Okay. All other metals except not the fixed. Okay. Also, other main group metals on the right. Okay. By that I mean over here, right? The main group in transition is sort of this dividing line right here. Okay. But we've got these main group metals over here: germanium, tin, lead. So compounds with lead and tin and bismuth, even though they're main group metals, they will have a Roman numeral. They can have 2 plus and 4 plus charges and other things there. So let's just say tin, lead, etc. Okay? So there is our exhaustive final list of which metals are fixed charge, which metals are variable charge. So at some point you should probably get in the habit on a blank periodic table of doing something like this: plus, 2 plus, 3 plus, 3 plus, 2 plus, 1 plus. I see a lot of students doing that kind of thing on a periodic table. That should be the sort of thing that you have written on the periodic table that you look at while you're practicing writing names and formulas of things. Okay? All of those other metals, if you're not given a charge, you have to figure it out from the formula. Okay? So let's go on